Well, it's a cold one. Today, January 6th, marks our coldest day of the season here in the Central Plains. Thanks for joining the Meteorology Lab channel. I'm Tim Vasquez, and we'll be taking a look at the weather around the country for the next half hour. And I'm here, as you know, I took a break last night to catch up on sleep, and I'm pretty well caught up, and we're ready to roll here tonight. Ironically, we're at the time of perihelion for the sun. This is when the Earth is closest to the sun. The Earth's orbit is elliptical, and just a couple days ago, January 4th, we were about 1.7% closer to the annual mean position of the sun. So, kind of hard to believe with all this weather going on right now. As you can see, we're pretty much, we got below normal temperatures just about across the entire country, except for Florida. The coldest temperatures on average by far, that's going to be here in the Rocky Mountain region and the Texas Panhandle, but we're definitely feeling the effects here in the Central Plains and the Midwest. These were the high temperatures today across the U.S. We got up to about 31 where I'm at, and it's reading 25 right now. Highs were pretty much in the single digits and tens across the northern plains. Here in Texas, just teens and 20s. We haven't really looked at the satellite much in the past few weeks. Might as well look at that now, and you can see that the more colorful shading, that corresponds to the colder air. In through here, a lot of this darker green, the satellite is actually sensing colder ground, colder surfaces. And we can pick up a little bit of high cloud through here. This is the upper level disturbance working its way eastward, and I'm going to show that to you on the 500 millibar chart. Out ahead of it, some good moisture out in the Gulf of Mexico, streaming northward, producing a few showers and thunderstorms there in Georgia and Florida. We'll take a look at AWIPS here, and let me switch over to that radar frame. AWIPS has a pretty weird caching feature. If you turn away from it for a while, it blanks out the image, and you have to kind of wait for it to come back. But there's our shower activity. Heaviest stuff looks to be right around the Tallahassee area and maybe around Jacksonville, just south of there. Doesn't look like anything too severe from what I can see on this image. Behind it, this looks like all post-frontal air, and you can see we're picking up the striations to the north of Atlanta. That's indicating we're detecting solid precipitation. This is probably a good time as any to look at the surface chart. So I'm going to switch over to that real quick, and we'll start with Texas and Oklahoma. You can see we're starting to clear out here in Texas. The ASOS sites showing no lower mid-cloud through this area, but temperatures are pretty cold. 12 degrees there off the top of the chart there at Oklahoma City, 16 at Tulsa, and 22 at DFW. And up to the north, yeah, it's pretty cold up there for sure. Out in the southeast U.S., they've just had the front push through, and what we want to look at here is the leading edge of that front. You can see 72 here offshore off the South Carolina coast. So we're probably looking at that front kind of bisecting Florida, kind of like that. The front trails off into the Gulf of Mexico and then well past the Rio Grande all the way down to Veracruz, Mexico. And you can see how it's kind of banked up against the Sierra Madre Occidental. I think that's the Occidental Range, the eastern one. And yeah, look at that, 81 degrees there, contrasting sharply with this 37 just west of Laredo. And we actually had highs in the 90s in this area earlier today. Kind of hard to believe that, but where's the frontal position? Well, we can see it's definitely to the north of this area because it's quite warm there. Higher elevations here, 60s. That's pretty warm. Looks like we have to go all the way up to Arizona. We've got 61 there at Phoenix. That's probably on the warm side. Might have to go with something like that. 39. That's going to be kind of cold there in Las Vegas. Let me get that centered here. And we'll start picking up the southwest out in Ron's territory. Okay, there we go. Got that. 29 at Tonopah. That's going to be kind of about average for this time of year. 39 is pretty cold at Las Vegas, so probably going to go with something like that. Don't quite know what it is along the coast. We're going to have to look at the thickness chart for that. But you can see up in Oregon, they're in the core of the polar air. Single digits all through here and below zero in the Snake River Valley. So let's head over and check out the thickness. You can hear some gusty cold winds outside. We're getting a little bit of mixing with air mass modification as the air moves southward across our area and goes across warmer ground. That tends to destabilize it from the bottom up, and we get gusty winds as a result, and that's what we got going on right now here. So our thickness chart, thickness in isobars, here we go. You can see the main thickness band all the way down into the southeast U.S. here. Then it kind of fans out across the southwestern U.S. So I'm probably going to go with a frontal position kind of like this. Then it does become kind of indefinite out towards California. But as we go off the coast, I think we probably pick it up something like this with that next system off the coast. So pretty much high pressure and cold air infiltrating the central and midwestern U.S. here. And yeah, the 500 millibar chart, can't forget that. And we can see northwesterly flow is open across Canada and the north central U.S. And that's going to mean a cold pattern. And I've talked to you over the past few days about the blocking pattern. There's that Rex block right there. You see that right there? Northerly latitudes, we have a cutoff high over Alaska. And south of that, we have a cutoff low. So those are kind of parallel with the meridians here. And the flow is kind of split around that. So that's going to be that Rex block right there. So that pattern is kind of holding still with a big ridge across the Pacific area and a trough over the United States itself. And that puts us under this northwesterly flow. So right now we're seeing the trough axis kind of along that line right there. This is kind of where the trough is the deepest. And that corresponds to the core of some of the strongest polar air coming southward out of the Canadian region. So that's it right there, cold air on its way south. And let's take a look at the soundings, kind of get familiar with this. Let's look at the Fort Worth sounding. This was taken an hour ago, so you can definitely see the frontal inversion there. Do you see that there? Top of it is going to be right here. And we go over and read the pressure. 700, that's going to be about 10,000 feet. 800 is going to be about 6,000, so that puts the top of the cold air mass at about 8,000 or 9,000 feet at DFW. And above that, this is pretty important. There's not much humidity above that frontal inversion. Not much moisture. So because of that, we're not seeing an overrunning pattern. In fact, the flow is coming out of the west here, just above the frontal inversion. So we don't have good cyclogenesis coming up from the south, pulling moisture northward, and there's actually not much moisture on tap to the south. This is the water vapor imagery here. So do we see the Pineapple Express set up over Texas? No, we don't. That is what would help us with a snowstorm event if we had a big plume of moisture coming up out of Mexico. So we don't have that, and as a matter of fact, what we have is this subsidence here. So this is that warmer shading here on the moisture channel. This indicates downward motion affecting Dallas, and that's probably helping to build that, that inversion from the top. But we are picking up a little bit of the cirrus up here. And I don't know if any of you who are very savvy with reading the sky and looking at clouds, I don't know if you saw that cirrus on the time lapse. Most of what you saw in there was stratocumulus. Let me roll that and show you the time lapse here. Nope, not that one. There we go. So take a look at this. Do you see the shadows riding overhead? These blotches, and you see the sky just kind of changing and going from like very dark and dismal to very bright, just alternating back and forth. That's the high clouds up at about, let's see here, it shows about 23,000 on top of the stratocumulus layer that's feeding from right to left here. So there's a little bit going on there aloft, and we can see that on the Scuti there. And that's that cirrus right here. In the stratocumulus itself, that's going to be that layer right there. And you can see that cirrus riding along very quickly at about 105 knots. Okay, let's see. I think we're about done here with the analysis. Maybe we can look at the SPC mesoscale analysis just to pull something random up here. Let's change sectors and go into the southeast U.S. Okay, let's see what field do I have here. Let me check down here at the bottom. 925, height and temperature. What I'd probably like to look at here is a moisture field. So I'm going to go to, let's see, let me show you the menu here. Let's see, for looking at moisture, what do we have for moisture aloft? Let's see here. We don't really have too much, and this is really where wind grids comes in handy, because you can actually look at mixing ratio and dew point just off the surface. A lot of these online sites are very limited for that, but we can go ahead and pull up the temperature, wind, and dew point. Okay, so what we're looking at here, the moisture is going to be this green shading. And it's actually calibrated with these blue lines. You see these blue dashed lines in here? So if you look strictly at the blue lines, this is kind of like the edge of the moisture right there. So that's kind of representing the edge of the tropical air mass, kind of located right here in northern Florida. When you get north of that, you get into the polar air mass itself, and temperatures and dew points drop off quite a bit. But aloft, just off the surface, some of that tropical moisture is coming over the top of that cold dome, up at about 2,000 to 4,000 feet. And that's helping to feed some of these cells here. So that gives you a little bit of an idea what's going on. And for evaluating the storms out here, actually in the warm air, we would like to use the 100 millibar mixed layer. Let me show you where you can see that. Thermodynamics, 100 millibar mixed layer. So you're going to use that when you're out in the core of the tropical air. Now, one problem here, a lot of people don't really get this when they start using these products, is that the field has already been distorted by this MCS here. So you might be looking at this line here and thinking, there's no moisture here, or there's no instability. Well, yeah, there is. It's just being distorted by that MCS, all those storms there. So you kind of have to look at the field you have here and just kind of interpolate. I mean, obviously the instability is going to be lower in this area, but the general field, ignoring the storms, it's going to look something like that probably. And that brings 500 to 1,000 joules per kilogram CAPE up into this region. And that's not in the severe category, but that's definitely in the thunderstorm, maybe strong thunderstorm category there. What about north of the front? What do we have for up there? Well, you can't use the 1,000 through, the 100 millibar mixed layer. You can't do that at all because the lowest 100 millibars, that consists of cold polar air, and that's going to give you no instability. The key layer we're interested in is just above the frontal inversion, and the best CAPE value for capturing that is going to be the most unstable CAPE. And so that'll get you back behind the front and let you look at the instability there. And what we can see here, just only a very small slice of higher CAPE, just like 200 to 400 joules per kilogram up northward, and there is some distortion from the existing convection here. But one thing that's really a key here is in this area where there's no convection, there's also no instability. So the severe potential north of the front looks kind of low here. So that's our little refresher here. I'm going to try to look at the SPC mesoscale analysis products every now and then because spring is going to be here in just 3 or 4 months. And then we're really going to be using this site. So let's get geared up to look at the forecast, and let me get the charts all set up here. Okay, so that's right now. That's the GFS. And let me see what's going on in chat here before I get started on that. Quite a bit of activity here. Kevin woke up in the middle of the night, and lo and behold, I was finishing up. Yeah. I got up last night probably about 1 in the morning, and I realized I'd slept through the webcast, and that kind of sucked, but I figured I should go ahead and just do an episode anyway, so that's what I did. I had about maybe 3 people on at the time, but we got it done, so that's good. Morristown issued a winter storm warning for East Tennessee, 2 to 4 inches. Okay. What surface chart am I using? This is going to be digital atmosphere. This is a program that I actually wrote. The bulk of it was written about 10 or 15 years ago, but I'm still continuing to work on that. And that's the little pop-up there. Let's see. Significant to major atmospheric river event with heavy rain and gusty southerly winds. Okay, this is California. That's from Felix Lopez, and I forgot to point that out. Let me show that to you real quick. That's going to be way out to the west. Let me see, where did I put that chart? Yeah, here it is. You can see that system off the west coast right there coming in. So that's the next big event, and we're going to see that in a minute on the GFS chart. So this we can definitely see on the water vapor imagery. This is probably tapping some fairly potent Pacific air. And maybe I can show that to you. Let me just pull that up. I'm going to go to the NASA site for satellite imagery, GHCC, West water vapor. Okay, they changed some links around. Let me get that set up here. And just, if any of you want to go to the site, that's it right there. It's going to be weather.msfc.nasa.gov.GOES. So our western, goes western image. There we go. There's the water vapor imagery, and let me give you a enhanced version of that real quick. I gotta type some stuff in here to get that working. Zoom factor to low. Okay. There we go. So that's the next system heading into California over the next couple days. And yeah, look at that plume of moisture coming northward. In fact, looks like two of them right here. So the moisture is on the way for California. And we've got a pretty classic baroclinic system appearance here. See that comma right there? And when we see that, we can pretty much assume for a starting location of the jet stream, it's going to be something like that right there. And then any large shortwaves, that's probably going to be located somewhere in here. So just looking at the satellite imagery, you can use this pattern to kind of put that together and see what you expect on the upper level charts. Okay, anything else on the messages? A lot of activity here. Kevin got his bread and groceries, good deal. And does the big trough over the U.S. suck in the Pineapple Express? Yeah, it does if it digs far south enough. They're not in phase right now because the Pineapple Express thing that we have out in the Pacific, that's kind of buried within that big long wave ridge. But if this long wave trough here retrogresses a little bit, then yeah, that'll pick it up. But anyway, that plume of moisture is going to eventually move into the U.S. as the subtropical jet gets going there. Okay, let's move forward. Okay, we've got snow in Mississippi and Alabama there. You can see that showing on the GFS there. Remember, the front is to the south. And let's see what we've got for our webcast tomorrow. It's going to be Saturday. You got the weekend coming up. Got a big ridge here in the central U.S. So the strongest cold air advection, that's going to be in the Midwest and the Appalachian region, kind of like that. And Texas is going to start bringing in some warm air advection in the high plains in Colorado. It's obviously going to be a very cold start, but it is warm air advection nonetheless. And here's California getting active here. And we can see there's a very strong southerly gradient there along the Pacific coast. Now I'm going to show you something new here, whether the Gulf is open. When we talk about the Gulf being open, that's are we bringing in moisture from the tropical latitudes? So we like to watch this area, and especially way down in the Bay of Campeche, down to the south there between the Yucatan and Mexico. So the gradient we have there in the western Gulf, that's a northerly gradient, so that's going to be kind of cold northeasterly flow. Gulf is not open. Then for Sunday's webcast, still got high pressure across the eastern U.S., warm air advection in Texas and the central U.S. Is the Gulf open? Yeah, it's starting to open up a little bit. We've got easterly flow onto the Gulf Coast, but the trajectories, those are coming from Florida. Let me draw these arrows here. So the air is flowing from the cold high over the eastern U.S., coming over the Gulf, and then onto the Texas coast. So that's going to be some fairly cold air. We're not tapping the very deep moisture off to the south. Okay, then for Monday's webcast. Now we've got very extensive warm air advection across Texas and even some downslope Got the lee side trough there in Colorado and New Mexico. Downslope flow, so we probably are going to get a pretty good warm-up here in Texas. How about the Gulf? Is that open? Yep, it's pretty much open, but we're still pulling in trajectories from recirculated air. The best moisture down in Mexico, that's probably starting to wander up through northeast Mexico like that. And out in the Rockies, there's our next system coming through this region here. Very stormy pattern there for Monday. Then it looks like for Tuesday, looks like that system moves eastward pretty quickly out through the Great Lakes. Fronts are going to be looking like this. This is just a quick frontal analysis. And it looks pretty warm for Texas, and it looks like we are tapping a little bit more moisture out of the Gulf, and it's making its way up the Mississippi River. So probably a chance of showers through that area as the front comes through. And for Wednesday, high pressure across the Midwest as that front comes through that area, and Texas gets a bit of a backdoor front here. See a little bit of backdoor frontal passage. So Red River will probably cool down a little bit, but remains warm for central and south Texas. Then moving into Thursday, got a new polar outbreak. So that's on its way south. And it looks like the Gulf is pretty well open. So now we're pulling in trajectories from the deep southern Gulf. And because of that, now you can see we're developing a little bit of shower activity there in Arkansas and near Memphis. Okay, then for Friday, coming up for next weekend, Friday, January 13th. Looks like the front kind of stalls there in East Texas. And got kind of a showery pattern there, and you can see a little bit of isentropic upglide over Oklahoma and the Texarkana area. And some of that moisture makes its way northward, and we get a little bit of snow shower activity in Nebraska and the Dakotas. Looks like a new baroclinic system coming through New Mexico and Colorado. Let's see what that does. Gives us a winter storm. And the GFS has got it for Oklahoma. Well, as far as the low position, but a lot of the inclement weather, it's putting it around Kansas City to Salt Lake or to St. Louis on Saturday. And by the time we do the webcast on Saturday evening, got ourselves a full-fledged frontal system in the Mississippi River Valley. And the front comes in through Texas like that. Deep moisture fetch from the southern Gulf, so that'll be good for thunderstorms and showers in the Mississippi River Valley. And 540 line, there it is coming into Oklahoma. Looks like probably not as severe as what we had this week. Then for Sunday's webcast on the 15th, front just continues pushing southward into the Gulf, and it looks like we've got a pretty deep fetch of moisture coming out of there. And as a result, we're getting a lot of shower activity and even some snow showers there in the Abilene area. 16th on Monday, frontal system making its way through the southeast U.S., and it looks like not much winter weather, kind of confined there to Indiana and Ohio. And for Wednesday, the 18th, it's like we've come under the influence of a big, kind of like a Pacific high, a little bit of an Alberta clipper moving through Illinois. And now we're starting to get to the end of the reliable data. Looks like things moderate quite a bit, got kind of a very strong zonal component, very strong westerly flow, and a very pronounced lee side trough there in the Rockies. So it looks like things will probably start finally quieting down after the middle of the month. And let's take a quick look at what the Canadian model has got. I'm not going to run through the whole thing, but we'll see if there's any differences. I didn't really pay too much attention to this area. I'm sorry, there's too much to look at, but when you get a chance, you may want to compare that with the GFS and see what that does. What I was looking at in particular was this backdoor front coming into Texas. Looks like the Canadian model kind of pushes it all the way. I don't know, it's pretty similar to the GFS there, maybe pushing a little bit further. And then we get that downslope flow picking up here. Otherwise, it looks pretty similar to the GFS. All right. 31 minutes there. It was quite a webcast there, but had a lot to look at. If you have any special requests of anything you want to cover tomorrow, man, I need to get in there and look at those comments on YouTube. I'm sorry I haven't really gotten to that. I'm going to do that as soon as I get off here and check that out. Social media is kind of hard for me to follow and keep track of. There's so much stuff going on, so I will get to that. But YouTube is definitely a good place to leave feedback, because if I go in there, I will see it. Also, you can use my contact page at weathergraphics.com. That'll work too. Okay, I hope you all have a good evening, and let me bring that down, probably getting some echoing there. Anyway, have a good evening, and we'll see you tomorrow at the usual time, 8 o'clock, and have a good evening. Bye-bye.